Hola chicos, I'm coming live to you from the very small mountain town of El Progreso in Galapagos, Ecuador. And it looks like an abandoned city. I'm just here with Chris Mell,
Hola.
one of the marine biologists with whom I'm working on the shark meat project. We're gonna update you on this project along the way of our 50-kilometer mountain bike hike. So you can see that for now we're still in pretty decent physical shape, even though it's really hot. I mean, you'll see along the way, we'll update you and you'll see our physical strengths decreasing, but we'll update you on the project, why we're here, what we're doing, and why it's actually an interesting project in the first place. And on that note, we have to go and we'll talk to you along the way. Cheers. So we made it. Look at that. Pretty cool beach. It's called Puerto Chino. And we made it. And we had a flat tire, so it was quite an adventure. But we're here. And now we're gonna have the biggest hike that I've ever done, mountain biking. But first, we're gonna talk a bit about the shark meat project. So Chris Mell, can you tell us who you are? What are you doing in your life?
So I'm a postdoc at Dalhousie University in the Integrated Fisheries Lab, and I'm working as a part of the Global Shark Meat Project. So our goal is to understand how much of each species of shark and ray is caught, traded, and consumed as meat products each year. So there's been a lot of work that's been done on the fin trade in the last couple of decades, but our goal is to sort of move beyond that and look at meat specifically. And so our project is focused on solving a couple key issues. So the first one being how many of each species are caught. So we use data sets that are recorded or reported to the FAO as part of their statistics program. One of the issues with it is that some countries are very good at reporting how much they're catching of each particular species. So for example, we would know how much blue shark they caught, how much hammerhead shark they caught. Some countries do not report any of that resolution in the data. So all that we know is that they've caught a certain amount of sharks and rays. So our goal is to use the information available through the landings databases, but also expert opinions on the importance of specific species to fisheries to sort of decompose that in a probabilistic way. So what's the probability of them catching so much blue shark, so much common thresher shark, so much short-fin mako shark? And doing that across a number of countries so that we can identify the actual species-specific catch.
Now, can you tell us why that's important and interesting to actually study that?
Yeah, so there's a couple of reasons. So the first thing is that sharks and rays are one of the most threatened groups of vertebrates on Earth. So IUCN Red List Assessments, that's the International Union for the Conservation of Nature, has estimated that a third of all species are at risk of extinction. And the reason that this is important is that a lot of international regulations of trade are at the species-specific level. So a lot of this is done through what's called CITES, which is the Convention for the International Trade in Endangered Species. So species that are listed on CITES technically are regulated. So if anything is Appendix 1, for example, that would be things like sawfish, rhinos, elephants, those cannot be traded. But if something is listed under Appendix 2, it can be traded provided the exporting country produces what they call a non-detriment finding. So if they can demonstrate that their harvesting of a particular species doesn't impact the population, then they can get a permit to export that. But the CITES regulations are at the species level, so we need to know which species are actually being traded.
Can you tell us about the main objective, that the grand finale basically of that study?
So our goal are to sort of produce three primary outputs. So the first one being understanding the species composition of the meat trade. So trade is even a bit more tricky than landings alone, because all we know currently is whether or not countries are trading shark meat or ray meat. So we're going to leverage the species-specific landings information we get from each country with demand scores and the species composition between trade partners to infer how much trade is occurring for each specific species. The second one is to do that same sort of approach, so to understand the species composition of landings. And this is really important because population trajectories are species specific. So if you looked at the FAO landings, in the sort of around 2010 to 2013, there was a peak in global shark and ray landings. But this was sort of masked by the fact that a lot of fisheries had expanded and they were catching a lot of blue shark. So some species were actually declining while landings of blue shark was increasing. So without knowing the specific species composition of the catch, it's hard for us to really understand what's going on with specific populations. And the third output we want to have is understanding what sort of factors correlate with consumption across countries and regions. So are there particular aspects of cultural traditions, culinary traditions, socioeconomic and livelihood factors that impact how much a country would consume in total and in per capita as well.
Yeah, because you told me that actually shark meat and ray meat are actually like, they are traded quite a lot. I didn't know that before the project, but they are traded quite a lot. And maybe some people have eaten shark meat without even knowing it.
I think
right?
that's a really common thing in seafood in general, sort of mislabeling. So there are lots of places where people have probably consumed shark without knowing it. So oftentimes if you are in Australia or Europe and you have fish and chips or flake, oftentimes that is shark. Typically in Australia it's small-bodied sharks, things like dogfish, school sharks. But in a lot of places, monkfish or things that are marketed as monkfish are often angel sharks, which are a flat-bodied species of shark. So this occurs not just in sharks and rays, but in all sorts of different types of seafood, that mislabeling. So a lot of people might be consuming sharks and not knowing it, but there are also a lot of countries where people do traditionally eat shark, so they know. So in Brazil, for example, cazón in Mexico, so a lot of places in Latin America would eat shark. In Europe, they eat a lot of rays and skates, and also in parts of Asia and the Pacific. There are lots of aspects, lots of contexts in which shark and ray is readily eaten and people know, but it is also marketed unbeknownst to consumers.
Yeah, and to be clear, these are authorized species of sharks and rays, but it's just for marketing reason they are not labeled as sharks and ray because people are less willing to eat shark, basically.
Yeah, I think it's
right?
So these are all the majority of them are going to be legal fisheries.
Yeah.
We can't say that they all are.
Yeah.
So most shark and ray fisheries aren't really effectively managed. They can be, but they often aren't. But I think it's more often, because you see it in species of bony fish and other things, it's just a marketing thing. People are more likely to buy Chilean sea bass, even though technically that's what we call Patagonian toothfish. Mm-hmm. So it sounds a little more appetizing if it's Chilean sea bass. So that marketing is a strong factor as well.
Yeah, but I think it's important to draw that distinction between what's legal and what's basically mainly marketing thing.
Absolutely.
And so you're also doing some tagging projects, right, of rays and sharks, which is a different project, but can you briefly explain what tagging means and why it's useful for scientific research?
Yeah, so tagging typically refers to understanding the spatial ecology of a species or its movement behavior. So typically with sharks and rays, we'll use a few different types of tags. So there are traditional tags, which would just be sort of an external tag with an ID. So you'll know where a fish was first landed, tagged, and if it's recaptured later on. We also use acoustic tags, which send out an acoustic signal, which will be picked up either by a person tracking them actively with a hydrophone or through a series of acoustic receivers, which are often deployed in a specific area to capture where sharks and rays might be moving. And then for really big species, we can also use satellite tags. So these are typically for larger oceanic species. So we have pop-up satellite archival tags, which can record a species' depth and temperature, and they'll pop off after a certain amount of time. Or there can be spot tags, which are sort of instantaneous positioning tags. So if you put them on the dorsal fin of an animal, as soon as that breaks the water, it can send a signal to a satellite. Also, you can use it to understand how species might interact with fisheries. So we know where fishermen are fishing, but are sharks swimming through there, especially if they're not a target species. So a lot of sharks are caught sort of incidental bycatch, we call it. So especially in high seas tuna fisheries, so things like blue shark and shortfin mako are captured quite frequently because they're in the same areas and they can be attracted to long lines. or even caught up in purse-aids. And then understanding how populations sort of structure themselves. Do you have distinct populations with individuals moving between? Is there mixing and these types of things? So all of that is really important for managers to understand, to use the appropriate population dynamic models to understand what the population is doing and how it will respond to fishing pressure. Overall, the question is to understand how species move, and it can be important for a number of different things. So one of the most common measures for conserving shark populations is spatial protections. So setting things up like marine protected areas, where specific areas of the ocean will be either closed completely to fishing or closed to fishing certain types of gear, certain times of years. So in order to make that really effective, you have to understand where the species you're trying to protect are going.
Yeah.
And this is a really pertinent one because one of the UN sort of Convention for Biodiversity goals in the next 10 years is to establish what they call 30 by 30. So by 2030, they want every country to have at least 30% of their exclusive economic zone, which is 200 nautical miles from your coast, to be set aside for spatial protections. So understanding how species use these, what their residency time is, how far they disperse, and sort of optimizing the design of these spatial protections is really important.
So you've told me that you were into sharks since you were 5 years old, so I have to ask you if you have a favorite species of shark.
I do have a favorite species of shark. It would probably have to be the California leopard shark. So this is a small triachid, so it's a hound shark, Triachus semifasciata. I think the reason it's probably my favorite is, first of all, they're really distinct. They have this sort of saddle coloration. You might have seen them in aquariums and stuff. And I also always used to see them when I was growing up surfing in places just like this. You'd be going through the waves and you'd see sharks underneath. So it's kind of what kicked off my sort of fascination. But I also have to say I really, really love rays as well, which often get overlooked.
True.
And I've spent a lot of time working on probably the least charismatic ray, the round stingray, Urobatus halleri, but it has a special place in my heart. So they're not very big. I think 30 centimeters discrete would be the maximum size. But you can see them in really dense aggregations along the Pacific coast. Not really important for fisheries, but just one of my favorites.
Yeah, and we've actually seen an incredible manta ray when we were doing some snorkeling the other day. We were on a boat going to the snorkeling place, and then somebody on the boat spotted one, like the manta ray, and then just out of nowhere, like everybody was looking at that spot, and then the manta ray was just like basically jumped out of the water, and it's huge. Like manta rays could be
probably at least that one was 3.5 meters.
Yeah. Yeah, so like that one was medium. Apparently, for me it was huge. I don't know, but like Chris told me it could be like 5-6 meter in amplitude.
The giant oceanic manta, Mobula barostris, can get up to I believe 6 meters displaced. But this was still a big ray.
Damn. So you see, rays are cool too. If you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
I was thinking about this as we were pedaling up the mountain, and I wanted to pick something a little bit different than what you have probably typically here. But probably if I had to pick someone, it would be Ed Ricketts. So most people might know him from Steinbeck's books, The Log from the Sea of Cortez. Also a fictionalized character, Doc, in Cannery Row at Sweet Thursday. He was sort of a preeminent marine ecologist in California. So he actually wrote some of the sort of foundational textbooks about coastal ecology, specifically inverts from the intertidal. So between Pacific tides, and a lot of that was informed by his work on travel with Steinbeck in the Sea of Cortez and places like that. But I think the thing that I would really admire would be his naturalist perspective. I think we live in an era of big data, which is really fantastic. Those techniques have exploded and they're really great. But I think oftentimes what might be lost is sort of the context in which that data was collected and what it actually means. So the larger and larger scale you get, especially the global scale, what might be true in one area is not necessarily true in another. So it can be with regards to different species or even the same species in different locations. So I think one thing that's really important for people who work in the modeling space and think about this is think about the actual biology and natural history of the animals in which they work. Plus, he was the only person that I knew that on a hot day like today would advocate for what they call beer milkshakes.
That sounds terrible.
Quite delicious, actually.